Hello, Introduction to Java Programming. In this session, let's discuss about methods in Java. Let's begin. Methods and functions both are synonyms. In C and C++, we call these things as functions, and in Java, we call the functions as methods. What's a function or a method? Literally, it is something like this. It's a self-contained block of code to perform a particular task. It's a block actually. So how do you represent a block? Any block is represented with the braces in C, C++, and Java. Okay, so the block contains what? A block contains statements in it, programmatic statements in it, one or many. Okay, and this block has a name, right? So that's why we call this as a self-contained block of code, and that block has a name. And why we write this code? To perform a particular task. In fact, in Java, the code will be as part of a method only. We will write all our business logic in the methods only. In fact, not in Java. Whatever the language you take, your code will be there as part of certain methods, and we will call those methods. And there is one property for a method. That property is every method should return a value back. Whatever the method you write, it should return a value back. That's why whenever we write any method, we'll specify the return type. In fact, for our main method also, you can actually see public static void main. Main is a method and we are actually specifying the return type. And here we are telling void. That means void returns nothing. Every method by virtue has to return a value back. If you are returning any value, so you have to specify its type, return type. Integer, float, double, character, boolean, or any class type like string or whatever the class you write. If you don't want to return, we have to specify with void. Void is a keyword. It says return nothing. So what are the advantages of methods actually? Why we have to write methods? Okay, so in order to understand why we have to write methods, let's actually understand the problem. So let's go over here. Let's understand why we need methods. We'll actually understand through a program. Now I have a task actually to add 1 to 10 numbers and 21 to 35 numbers and 51 to 75 numbers. And of course, you can also have one more task if you wish. Okay, so here I want to find 1012, let's say 1111. So those many numbers, I have to add these many numbers. So this is my task. This is the task given to me. How do I solve this? I have to add 1 to 10 numbers. My code, I will take a for loop and I will write like this. For int I equal to, so what is the value? So you have to start from 1 and then you have to go up to I less than or equal to 10, and every time you have to increment it I plus plus. So what we need to do, we have to add actually. Let's have a variable called sum1. So sum1 equal to the sum1 plus this particular I value, right? So what is the sum1? So sum1 is to store first 1 to 10 numbers. So int sum1 equal to 0. Okay, so this is the code actually for adding 1 to 10 numbers. Now I have a similar job to do actually. Here I have to add 21 to 35 numbers. So what I do, just I will copy paste this. I just copy paste this and I will do over here something like this. And someone, since I'm using it, I will call this as sum2. And here I need to find the sum of 21 to 35. So I value equal to 21 and I less than equal to 35. And sum2 equal to sum2 plus I actually. That's it. Okay, so now I have to find addition of 51 to 75. Now what I do actually here, I just copy paste here this code and I will say sum3 and int I equal to 51, then go up to 75, and now I say sum3 equal to sum3 plus I. Okay, And to find 1012 1111, the similar logic actually is required. So I will just again copy paste this. So this is sum 4. Now it is actually sum 4 to me. Okay, sum 4 equal to 0. And this actually starts from 101 and goes up to 1111. And sum 4 equal to sum 4 plus I. Right, so this is how I am doing. But if you observe, almost all the code is same. So the same code, same code, same code, same code. Okay, that means the code is getting repeated. Only the range values actually differing. Right? Yeah. So of course, this will solve our problem. This will solve our problem. I can compile and run. Let me actually compile and run this one. So Java C first, Java C first.java. It got compiled. There is no problem actually. And when I run also, when I run here Java first, now I will see. Okay, I think I'm not printing it, right? Okay, I have to print it. So I am not printing at all actually. So yeah, this print statement I have forgotten actually. Let me print this one. This is sum 1. Okay, so this also I have to copy for all the summations. And here I have to copy, and just I need to give a different values. That's it. So this is sum 1, then this is sum 2, then this will be sum 3, and this will be sum 4. Okay, so this will work, but we have so much of redundancy. We have so much of redundant code. See, first term numbers is 55, we know. Then 21 to 35 is 420, and 51 to 75 is 1575, and 1012 or 1111 is 612666. Okay, so it is working actually. But if you see, this is a redundancy. Again, here it is a redundancy. Again, it is a redundancy. Okay, so now how to solve with the methods actually? So what I do is, instead of writing this code again and again here, I will actually write a method. Okay, I will write a method called add actually. I will write a method called add. So how I'm going to write is, I'm going to write something like this, int. So int is my return type, add, and see, in order to add numbers, you require uh, two values, right? 1 and 10 here, and 21 and 35 here, the range values. So you require two values, right? So let's say int x comma int y. Okay, so this is a block. So method name, return type, and these are the parameters. Okay, so now what I want to do, I want to write the logic actually. So logic is something like this. Okay, so if you want to write int, it's okay. Otherwise, I just let me write void method only. Let me write void only. Later, I will make it to int. Void add int x into y. For int I equal to x, I need to start from x, and I less than equal to y. Okay, I plus plus, and here let me actually take some local variable. Let me take some local variable over here. Let's say the sum equal to sum plus I. So let me declare this variable. So int sum equal to 0. And I'm saying sum equal to sum plus I. Once it is done, what I'm doing, I'm just printing PL system.out.println some value. I'm printing the sum here. That's it. This is the method I have created. Okay, this is the method definition. Okay, I have defined it. Okay, since I have written this code over here, now I need not actually have all this particular code. So this code, all of this code I am actually removing. Okay, okay. So what I do is, I will remove, and I will actually call that method by passing these values. Okay, how I am doing actually? See, I will say sum of, okay, I'm calling that method, not sum actually. The method name is add. So add of, now I'm passing the range actually. So 1 comma 10. That's it. And this is done. This is no longer required to me. And for the next line of statements, I will just say add of this 21 comma 35. Okay, and this is no longer required. And then I will actually say add of, now I am passing these values actually 51 to 75, and this is done. And finally I have one more similar to this, then I say add of 101 to 1111. Okay, and this is not required. Okay, so I have a method defined over here in my class. I have a method defined in my class and I'm calling it. But when you are calling from your static context, so you have to see that this method is a static method. Otherwise, you require some object. Only static method can be called directly with the class name that we know actually, right? So here, in my static context, my main is the static context, and I am calling this method, and this method directly I call because it's static. Okay, so this add is a static method, that's why I could able to call directly without need of any object. Otherwise, I require an object. See how actually my code has got minimized. Instead of writing so many lines, I'm actually writing the definition only once, and I'm calling. If I want 100 times, I will call this add method 100 times. Okay, so that's the use of actually the methods. So now this is the method definition. So what about these things actually? So these are method calls. This is a method call. You are passing certain parameters. Okay, so the parameters that you pass in a method are actually called actual parameters or actual arguments. Both are same. Actual parameters or arguments, because these are the actual arguments that you are passing, and these arguments you are actually catching them here, right? This is actually called formal parameters. So they are just formal only. Formal arguments are parameters. What actually values? 1 and 10 are actual values. 1 will be in X and 10 will be in Y. So in order to process, I'm taking them in a variable. That's why they are called formal parameters. And actual parameters will be as part of your method call. Right? So you have method definition and a method call. Method definition contains formal parameters. Method call contains actual parameters. So let me actually show you that it will work. Yeah, so let me compile this Java C first.java, and when I run, you can actually see the same output is getting printed, right? So earlier also we got the same output, but this is actually efficient code. I am not actually keeping redundant blocks of the code. Earlier I have 4 redundancy blocks. Same thing is getting repeated again and again. Just range values are changing. Rather, you can actually have a method and you can call. So not just like this, you can actually call any other method, add. Now you pass 111 and 1111. This much value. And you just add 11 comma 111. So this is also possible. Like that, you can actually call n number of times. This code is going to get executed. Okay, so once you write, you can actually call that one as many times as required. So now you can actually see the output is going to be like this. Okay, so this is actually the need for methods. Okay, so here we are writing a separate method, and that is method definition, and we are calling from the other method, that is my main method, because main is going to be my starting points. That's why I'm actually calling this. And when I call, this is called method call, which contains actual parameters. The method definition, you have the formal parameters. And one point here is, here when I call a method, that method is actually calculating the sum and it is getting printed also, right? So here itself it is printing. Okay, so now what I can do is I can actually change its return type, because it's taking integers and actually giving the sum in integers. I can actually change its return type actually to integer. So when it is returning a value, so then you have to use a statement called return. Okay, so what it is returning, it's calculating sum and it should return sum actually, right? My method, what I'm telling is I'm going to write a method called add, which takes 2 parameters which are range and finds the sum and returns the sum back. To whom it returns? Whoever the callers actually. So who is calling here? This add method is calling here. So now what I can do is I can actually call, I can actually take that sum into some int s, and int s equal to add of 1 comma 0, and then I can actually print that particular s. So this is how I can do that. Okay, and here I can actually rather than catching that into certain variable, I can straight away use my PL statement. Okay, and here in my PL statement, I will put my add method. Okay, I will put my add method call. So now what actually happens here? So add of 21 to 35 will actually give me, will return me a sum. So the sum value is getting printed straight away. That is getting printed straight away. So here I'm catching and I'm printing here straight away. Okay, so this is the easiest way to do actually. So now just take this and put all these values into here. Okay, that's all the problem. So you need not to catch separately into your variable, just use them in the method actually. So that will be fine actually. Okay, so now what happens when we call, that returns a value and that value actually getting printed. Okay, so this is a method with a return type actually. So you have to decide what you want to do. You want a return type or you want to write a void method. That's up to you actually. Okay, so something is missing. Yeah, so here actually one parenthesis is missing. So that's a problem. The copy paste issues. So now when I compile and I will actually get the outcome properly, right? So this is with the return type. Okay, method definition with the return type. So you can write with the return type or otherwise without return type also you can actually write. Okay, so that's what actually we are discussing here. So every method must return a value. If you don't want, then say void. And what is the use? Reusability. Okay, the same code I'm using again and again. The other thing is the information hiding. So when I call actually this method, I don't know what is actually it's doing. So its definition is written somewhere actually. That's called information hiding. And yeah, so method definition we understood. There should be a return type. There is a method name, and here arguments are parameters. These are called formal parameters. Then method body is required, and return type, return value is also required if it is non-void. Okay, if non-void means it's not void, return type is required. Okay, and this method name, this return type, method name, and parameters all together is actually called signature, method signature. What is a method signature? Means the method name, its return type, and the parameters combinedly called as a method signature. Okay, somebody asks what is a method signature? So method name with its return type and the parameters it takes is called a method signature. And this is the example how we have written. And so void method, I am not returning anything, rather I am printing some value here itself. And the method call. So if your method is returning certain value, you have to catch. Okay, otherwise directly you can actually use it in SOP statement. It's a void, then you need not to return any value. So directly that method will print the job actually, or print whatever the value it has to print it. Okay, so that's how methods are there in the language like C, C++, and Java. You know, Java has come from C and C++. So whatever there in C and C++ is available in Java also, but only the difference in Java is we call functions as methods here. Okay, and let's understand the last point actually that I'm going to tell you is varargs, variable arguments. Okay, so varargs in a method. So let me actually tell you. So varargs means variable arguments, but the name itself, varargs in the sense it's a variable arguments. Okay, what do you mean by variable arguments? Okay, let me actually tell you here. So I have a method here. It's an array, right? String array. You know, this public static void main, we cannot actually remove any public or static or void because they are mandatory. But what all we can change, args name can be changed, and the string array can be written like this: string dot dot dot. Okay, so how to represent where args means? So a variable name, let's say x dot dot dot. So 3 dots is actually var args. Okay, what does it mean? So var args means when you have an argument of var args, it can allow a variable number of arguments. Now you can pass variable number of arguments. You can pass one value, you can pass two values. That's what actually we are doing now. While when I am passing command line arguments, when I'm passing values from the command line, I will pass sometime 2 arguments, sometime 3 arguments, sometime 5, sometime 10, sometime I don't know how many I will pass. So we can actually pass variable arguments. Variable arguments underlyingly, so var args is underlyingly uh, is an array. It's an array. Actually, it is represented as an array. So we can actually say our string array args to string dot 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 actually. Okay. So for example, yeah, I want to show that it works actually. I want to show that it works. So if we change string to string dot dot, it will work. Let me actually show you this one. So later I will go to the concept of varargs. So let me Java C test.java. Oh, this is something else is coming up. Let me save this into my folder where I'm here. Yeah, this is actually, I have to save this into practice Java. So it's actually going to some other folder. So let me actually save this as test.java. Okay. Yeah, let me compile now. So then it will compile without any issues. Java C test.java compiled. And when I say Java space test, now you can actually see it works. Right. So what I'm actually showing here is string array can be represented as string dot dot. Okay, this is one thing actually. But what is the use of varargs actually? So let me have a method written actually here. So void add, same add method I am going to write here. Void add. But in here, what I am doing is I am saying int dot 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 x, int dot 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 x actually. Now what happens? This add method will allow variable number of arguments to be passed. Okay. So what happens? It allows variable number of arguments to be passed. So how that? Variable number of arguments to be passed. Okay. So in order to call this directly, I make this as a static method. I will make this as a static method. And here, what I'm going to do is, because the add method is going to sum actually, right? So I will take some s equal to 0. Okay. Now what I do, I will write a for loop because it has variable number of arguments, right? So now I will start with my I value equal to 0 because varargs underlying represented as an array. That's what I have written already over here. And I less than x dot length. I less than x dot length, then I plus plus. Okay, so here what I'm doing is sum plus equals to, so compound assignment operator, sum plus equal to this particular x of I. Okay, I can represent varargs like x of I because it's underlyingly an array. So after that, I just print my s value. Okay, so this is actually a method which is going to accept a variable number of arguments actually. So now what I do here, this is what I defined actually. This is my method definition, which is allowing variable number of arguments. Now I can actually pass variable number of arguments here. See, I say add 10 comma 20. Okay, and now this time I am actually passing 10 comma 20 comma 30. So first time I am passing 2 arguments. See here, I'm just passing 2 arguments only, parameters or arguments. So here I am passing 3 args. Okay, next time I can pass as many as I will not count actually. I will not count. Okay, so I am actually passing these many. So 1 to 9. Okay, so this time 9 arguments. Add of, now here I am passing some other arguments. I don't know how many I am passing, just randomly I am passing. Right? So you define a single method and you are passing variable number of arguments. This is varargs. If varargs is not there, so you have 4 method calls here. You should have 4 method definitions. 4 separate methods you have to define. But now you need not to define actually because it's a varargs. Okay, so that's actually the use of this variable arguments. Let me actually go here. Let me compile successfully and see now. First 10 and 20, 30. 10, 20, 30 is 60. 1 to 9 is 45. 1 to 10 is 55, of course. And other things actually I'm getting the value this. So varargs is very useful utility and you can always use and it will saves a lot of actually space and time, because you need not to write different methods for different method calls. Okay, it can accept variable number of arguments. And one last point about the variable arguments is, whenever you use variable arguments in a parameter list here, it must be only one. It must be only one, or see here, I have only one, or it it must be only one, or it must be the last parameter or last argument. So whenever you use, it must be the only one, just like this. If you have many parameters, it must be the last argument. Otherwise, what happens if it is not last argument? For example, if I say int y here, okay, so whatever all you are passing, it will take into only x, when y will never get a value actually. So that's why if at all you want to pass any value, so you actually take, for example, you want to take int a. Okay, now what happens? 10 will be treated as a, rest all will be x. Here 1 will be treated as a, rest all will be x. Okay, so then it will work actually. So it must be the first only one, otherwise it must be the last statement. So otherwise what happens? It compiler will give some error and it's not going to work in a proper way. Okay, so that's about actually the methods. Hope you have understood methods clearly. So method definitions, method calls, actual parameters, formal parameters, and of course, a variable number of arguments. Thank you.